Okay, so this is number 5B out of what, 10.2?
Yes.
Okay, so I'm supposed to verify that this thing solves this thing. Rewrite the system in matrix form, verify the given vector function satisfies the system for any choice of constants. Okay, cool. Alright, so first things first, rewrite. So I'm rewriting this as a vector y prime is the vector 3, 1, minus 1, 1 times y plus
what about the minus 5 et?
minus 5 e to the t e to the t.
Interesting.
Oops, God, why did that come up like that? Oh, is that that was the issue?
Yeah, but I mean, well, let's see how it plays out, because I'm sure there are several other places where I probably goofed, so.
Okay, so playing this out, I'm like, alright, okay, so if I rewrite y then, y is itself minus c1 e to the 2t, c1, sorry, I'm writing this kind of I'm saying this in a non-standard order. So the first column is minus c1 e to the 2t and c1 e to the 2t. And then the second column, oops, not second column, it is plus 1 plus t times c2 e to the 2t plus e to the t. And then so the first row, all told, is minus c1 e to the 2t plus the quantity 1 plus t times c2 e to the 2t plus e to the t. And then the second entry, right, is c1 e to the 2t plus c2, oops, I suppose minus c2t e to the 2t. And then plus 3e to the t.
Why aren't those separate columns?
Okay, so if I wrote that out a little slower, I'd do y is, and then scalar multiplication would say I have the vector c1 e to the minus c1 e to the 2t and c1 e to the 2t.
Right.
Right, that's just scalar multiplication for the first vector.
Yeah.
And then the second vector's scalar multiplication would be c2 times 1 plus t e to the 2t and c2, I guess, minus c2t e to the 2t. And then that last vector is an e to the t and a 3e to the t.
Yeah, I understand, but I mean, I guess that won't really have an effect when you're multiplying out, right? The A matrix times Y. Right?
Oh, yeah, this is the whole proposal for y, right? They've told me that y is all of these things. And yeah, I could multiply the A matrix times the first vector and the A matrix times the second vector and the A matrix times the third vector and then deal with it that way. That would certainly be an option that would work.
Okay.
I'm choosing to condense everything just because my next step's going to be to differentiate, I guess. You're not wrong philosophically at all. And in fact, it might prove easier to do it that way.
Uh-huh.
Would you rather do it that way? I don't mind.
mean, that's just how I learned. Like, I don't do like we didn't learn to do it the dot product way that you were talking about in class. On
Oh, okay. So let me just do it this way then. I'll pretend that y is written this way, which is fine. And then I need to calculate y prime, and then I need to shove y into this kind of equation, right? Okay, so y prime is going to be a minus 2c1 e to the 2t and 2c1 e to the 2t. And this next bit is going to be a, let's see, so a 2c2 times 1 plus t e to the 2t. Plus c2 e to the 2t. And the bottom there is going to be a minus c2 times e to the 2t plus 2t e to the 2t. And then my last term is going to be a, well, e to the t and a 3 e to the t. Cool.
I believe so.
Okay. So then, that's my left-hand side, right? And then my right-hand side, I'm going to need to take this whole thing and multiply it through by, oops, that's the wrong tool. I'm going to have to multiply it through by this 3, 1, minus 1, 1 matrix.
Mm-hmm.
Okay, so let's do it up. All right, so I can do that in pieces. So I'm just going to do those pieces. So my matrix is 3, 1, minus 1, 1. And I'm going to multiply by minus 2c1 e to the 2t, 2c1 e to the 2t. So this is just going to be my, oops, shit. What am I doing wrong? I did something very dumb.
Oh, you multiplied by the prime.
Yeah, I was trying to multiply by the derivative, and this needs to be times y. So I have minus c1 e to the 2t and c1 e to the 2t. And so when I do this multiplication, I get minus 3c1 e to the 2t plus c1 e to the 2t. And on the bottom, I get c1 e to the 2t. Oops, that was supposed to be a 2 in the top line. Plus c1 e to the 2t. Which gives me minus 2c1 e to the 2t and 2c1 e to the 2t. So that would be this piece matches this piece. That's good. Then I need to take 3, 1, minus 1, 1, and multiply it by my next guy, which is c2 times 1 plus t e to the 2t, and minus c2 t e to the 2t. And that's going to give me 3c2 times 1 plus t e to the 2t. Oops, not plus, but minus c2 t e to the 2t. And on the bottom, I'm going to have a minus c2 times 1 plus t e to the 2t. Minus c2t e to the 2t. Okay, and then that one's going to take a little bit more to check that it's the same. But this term should match that one. So let me see. I've got a 3c2 minus the c2, so I should have. Oh yeah, I'm gonna have to fiddle with that a little bit before I see that it's the same. But my hope would be that it is, right? I mean, if I differentiated correctly and if I multiplied my matrices correctly, I should see that those two terms are the same. So just simplifying a little tiny bit here. That is a 3c2 e to the 2t plus 3t e to the 2t, oops, c2, minus c2t e to the 2t. Okay, so this one is going to cancel with one of these. And so I should have 3c2, so 3 plain ones and 2 with t's, which is indeed what I have in the first line up there. And then on this bottom thing I have minus c2 e to the 2t minus 2c2t e to the 2t. And yep, that's what I have on the bottom on the middle term as well. So check. Blue is blue. Check. Okay, and then last thing I needed here is to check 3, 1 minus 1, 1 multiplied by what is that? Oh, just e to the t times e to the t and 3 e to the t. So I get that reads like 3 e to the t plus 3 e to the t. And minus e to the t plus 3 e to the t. And so I got 6 e to the t and 2 e to the t. And now I feel like something has gone real bad wrong, right?
Yeah, so that's when you add the negative 5 e to the t and the e to the t.
Yep, exactly. So those terms are a little bit disjointed. There's one here and this thing have to add together to be this one. So yeah, 6 e to the t minus 5 e to the t gives me e to the t. So this guy and this guy make that guy. And then 2 and 1 makes 3. So the bottom one checks out too. So red matches red, blue matches blue, and the 2 green pieces make the third green piece. Cool. Questions, things?
No.
Okay. So do you want to see the way you could have done this that would have saved you some time and effort?
Well, the way you did it, I don't write out like every single one individually. Like, I would have just had that A matrix and then multiplied it by the entire.
Okay. Yeah, and then you would have had this huge pile of terms to collect.
Not really.
Okay.
Because I mean, most of it I can do in my head. But...
There's kind of there's even another way to do this, which is to kind of going all the way back up to the top here. My intention is to take this matrix here that I'm going to call A, right?
Mm-hmm.
And really this part then becomes that I need to do AY, right?
Yeah.
Okay, well, Y is made out of this sum. So if I'm going to do AY, I may as well say that's A times C1. Actually, screw it. Let me just write this as V1 e to the 2t plus A times C2 V2 e to the 2t plus A times the vector 1, 3 times e to the t. And then the C1s and the e's are all scalar multiplications. Right?
Mm-hmm.
So those could really all just come in front of they can all just be pulled through the A's.
Okay.
And so really, if I want a super shorthand for this whole process, I may as well just calculate A times, like I can pre-calculate A times the vector minus 1, 1, and A times the vector 1 plus t, t, and the A times the vector 1, 3. And then I can just multiply those results by the C1 e to the 2t, the C2 e to the 2t, and the e to the t respectively.
Okay.
And that'd save me a lot of notation. It doesn't change the difficulty of what you're doing at all, but it means that instead of carrying all these constants and exponentials around and possibly losing a power somewhere or losing a subscript or something, you can just pre-calculate the vectors and then do the scalar multiplication, and then you're much less likely to lose subscripts or superscripts.
Right.
So,
a lot more sense.
Yeah. All right. Anything else?
No, I think that's it.
Okay.